Okay, you're right. Welcome to your video tutorial on working with indices. Now, we are still doing algebra. However, we're going to look at today what an indice is. Indices are those little tiny numbers like those squares and those threes and those fours and those fives, those little tiny numbers that sit on top or to the right of other numbers and pronumerals. So I was trying to think of a cool picture and look! What sits on top of your head? A hat! So what's better than a pictures of cute little puppies with hats on? Okay, I'm a bit mental. Anyway, let's move on. If we wish to calculate the following, n to the power of 4 times n to the power of 2, one way we could do it is by breaking it down. So I know that n to the power of 4 means n times n times n times n. Not n times 4, but n multiplied by itself 1, 2, 3, 4 times. And then I get n to the power of 2, which is n multiplied by n. Okay, twice. So that's 4 times and 2 times. And technically, if I do that, I could go 1, 2, 3, 4, 5, 6. They're all multiplying by each other. Okay, I can write that as n to the power of 6. But does anyone see an easier way we could do that? And I could break it down. Is there a relationship between what I've broken down and the numbers up the top here? 4 and 2. Oh, hold on. Wait. 4 and 2 is 6. So instead of having to waste my time by breaking it down, couldn't I just simply add the indices? If we look more closely, a much simpler method is just adding the indices, since the pronumerals are the same. I had two n's, one was to the power of 4, one was to the power of 2. Don't waste my time by writing it out and counting it. I can just add 4 and 2 together. We add the indices when multiplying only if my pronumeral or my base is the same. Now, these bases that we're talking about, we mean the pronumeral at the bottom. Okay, not the little number at the top, but the pronumeral at the bottom. If that's the same, if I have two n's like I did in my example, then I can just add the indices together. This is called an index law. Okay, so the indices are the little numbers at the top, and my base is the big number at the bottom. So, let's have a look at a few examples. Simplify k to the power of 4 multiplied by k to the power of 3. Now, I can either sit here and go k times k times k times k. Okay, that's the first one down. Then multiply by another k. That's the second one down. Multiply by 1, 2, 3 more. But to be honest, I'm wasting my life a little bit. So, as we agreed before, the quicker way to do that is to add these little indices together. But what do I do when I've got this k by itself? I don't have any indices. If you get a pronumeral by itself, it's the same as saying to the power of 1. We just don't bother writing it because of course it's to the power of 1. It's just itself. But when we're doing the index law and you're trying to add indices, if you see anything at all that doesn't have a number on the top of it, put a little 1 there. That'll help you when you're adding it. All I have to do here, guys, they're all k's. That's the first thing I ask myself. Is the pronumeral the same? Yep, it sure is. That means I can just add the indices together. So I add 4, 1, and 3. 4, 1, and 3, that's 8. So when I simplify this expression, I simplify it to k to the power of 8. Okay? It's actually as easy as that, guys. Let's have a look at another example. Okay. This one here. Now, this one's different. I've got numbers and I've got some pronumerals. So, let's deal with our numbers first like we always do. What's 5 multiplied by 2? Okay, 5 multiplied by 2 is 10. Now, I've got two e's. I've got e to the power of 10. I've got a 10 indice. And then I've got e to the power of 3, a 3 indice. I know with my index law, if my bases are the same, if my pronumeral at the base or whatever number there is the same, and I'm multiplying, I can just add the indices. So e to the power of 10, e to the power of 3 becomes e to the power of 13. The big thing in this example is I do my numbers first, then I do my pronumerals. Okay, always said that, guys, always said that. Do your numbers first, then do your pronumerals. Our last example here. The reason why I've thrown in this example is I have a different mix of pronumerals. So the first thing that we have to do is we have to deal with the numbers. I've got a 7, a 3, and a 2 all being multiplied by each other. Okay, 7, 3, and 2. Now it's multiplication, not addition. So some of you might sit there and say, but that's 7m and that's 3n, I can't add them. They, like terms, is only with addition and subtraction. This is multiplication, so it's different. 7 multiplied by 3, 7 3s are 21. 21 multiplied by 2. Now that's important. See what I did there? I've multiplied 7 by 3. I've moved left to right. 7 multiplied by 3, 21. 21 multiplied by 2, 42. Okay. Now I've done my numbers. My numbers are out of the way. The next thing I have to deal with are my pronumerals. I have two different types of pronumerals, okay? And so if I want my index law to work, I must only add the indices of the pronumerals that are the same. So I've got an m pronumeral there and an n pronumeral there. And then I've got an n pronumeral base there and an n there. So let's deal with the m's first. L, M, N, O, P. Yeah, I'll do the m's first because they come first alphabetically. M to the power of 3, m to the power of 8. 3 and 8 is 11, so it becomes m to the power of 11. Then my n's, I've got an n to the power of 5 and an n to the power of 4. That becomes m to the power of 9. Using my index laws, okay? M to the 11, n to the 9. And that's it, guys. That's literally all there is to indices.